So it's important for us to remember that when we are, this is actually the second page, I need to go back to the first page. It's important for us to remember that when we are writing an equation for lines or looking at something, the first place that we're going to start is the y-intercept. And so even though it says slope first, the first thing that I am going to always look for is the y-intercept. In this case, the y-intercept is right there at the origin, so the y-intercept is 0. The slope from one point to the next is up 1 to the right 2. So up 1 to the right 2, 1/2. And then the equation for this line, every single line that we ever write an equation for is going to follow this pattern. This pattern is called the slope-intercept form, and it is written out as y equals mx plus b. The reason that it is called the slope-intercept form is because that, the letter m is the value that's going to represent our slope, and b is going to be the value that represents our y-intercept. And so the y and the x are always going to just stay there the same. This value is going to get replaced with the slope. This value is going to get replaced with the y-intercept. So when I write out my equation, y equals mx plus b, all that needs to happen is I need to put the slope and the y-intercept where they go. So y equals m is the slope, 1/2, x plus b, which in this case is 0. Moving on, we need to find the y-intercept here. The y-intercept is -3. It's where the line crosses the y-axis. The slope, if we start at a point on the left, I need to go down 2, so that's -2, and to the right 2, that's +2. So our slope is going to be -2 over 2. The equation y equals mx plus b, y equals -2 over 2 is the same as -1 over 1, x plus a -3. Now this is a case where we are going to have to be careful at the end there, because it is not okay to have a plus -3. We can only have one sign, so I actually need to rewrite that as y equals -1 over 1, x minus 3. So the one I'm highlighting green is correct. The one that I'm highlighting red would not be acceptable. We cannot have a plus -3 at the end. It should only have one sign there anywhere in the equation. So this one we're going to pretend here that the slope is, that the y-intercept, we can't identify it exactly, but we're going to pretend that the y-intercept is at -3.5. And then, so -3.5 will be our slope, our y-intercept. And then slope, from a point on the left, I go up 1 to the right 2. So up 1 to the right 2. Y equals mx plus b. Y equals 1/2 x plus a -3.5. And so I have that plus and negative again. I need to deal with that. Y equals 1/2 x minus 3.5. Again, you have to rewrite it with only one sign between the 1/2 x and the -3.5. Otherwise, it would not be acceptable. Moving on to the next, our y-intercept is obviously at -1. Our slope is down 1, 2, 3, 4, 5. So down 5. And to the right, 1, 2, 3, 4. So again, y equals mx plus b. Y equals -5 over 4. X plus a -1. Need to clean up those signs. Y equals -5 over 4, x minus 1. Number 5 is an odd one, and I circled it because we are actually going to have a different conversation about this. The y-intercept is -1, and the slope, it doesn't go up or down at all, so that is a slope of 0. And the equation for this one looks a little bit weird because we're going to have y equals mx plus b, and so we're going to have y equals 0x plus the -1. Now 0x, anything times 0 is 0, and so that 0x is just going to go away. And then the plus -1 will turn into a -1. So this equation is simply y equals -1, and what that means is it doesn't matter what the x value is. It could be over here, could be in here, could be on the y-axis, could be over here, could be over here. It doesn't matter where I put a point. The y value is always going to be -1. These ones that have a slope of 0 or the ones that are undefined are kind of weird. So this one, I'm going to tell you what the y-intercept is. The y-intercept is 9. It would intercept the y-axis up here, and the place that would catch it would be the value 9. And so our slope would be up 1, 2, 3, 4, and to the right 1. So up 4 over 1. Equation y equals mx plus b. Y equals 4 over 1 x plus the y-intercept, which is 9. The next one, slope, the y-intercept is -5. Slope is going to be down 1, 2, 3, 4, and to the right 2. -4 over 2 is equal to -2 over 1. Y equals mx plus b. Y equals -2 over 1x plus a -5. We need to clean those signs up. -2 over 1x minus 5. Number 8, we have a vertical line that actually is the y-axis, and so this slope is undefined. The y-intercept is everywhere. This problem is extremely weird. And so the equation for this would be, let's look at y equals mx plus b. We would have y equals an undefined slope. This is a strange one. I'm going to have to think about this for just a moment. What would the equation here look like? The equation would look like x equals 0, because that vertical line always has an x value of 0. And I get that that one's a weird one. We're not going to worry about it. We're just going to move on with life, recognizing that you're almost never going to see something like that, and it's basically not important. So for our purposes, back here on the back, what we do need to do is make sure that we are identifying points where the line and the grid meet perfectly at a corner. So there is one, there is one. That right there is close, but if you look, it does not meet exactly at the corner. We could not use it to find the slope. We have to be very careful with that. And so the y-intercept in this case is 4. The slope is up 1, 2, 3, 4, 5, 6, 7, 8, and to the right 3. So up 8 over 3. And then the equation, y equals mx plus b. Y equals 8 over 3x plus 4. And then next we're going to pretend that I know what that y-intercept is. We're going to say it's 0.5. And again, we're going to look for opportunities where it crosses the grid exactly at a corner. You could pick any pair of those points to use to find the slope. I think I'll use the two in the middle. Down 1, 2, 3, and to the right 2. Down 3, to the right 2. We would have y equals -3 over 2 x plus 0.5. Number 11. We're going to pretend that that is -2.3 for our y-intercept. We're going to look for places where this catches the corner perfectly. So there's one, and there's another one. So negative 2.3 is what we will call our y-intercept. Our slope will be up 1, 2, 3, 4, and to the right 3. Up 4, to the right 3. So our equation, y equals 4 over 3x plus a negative 2.3. That needs to be rewritten. Y equals 4/3 x minus 2.3. Number 12. Our y-intercept is obviously 1. Slope, we need to find places where this crosses the grid perfectly at a corner, right there. And then another one right there. So our slope would be down 1, 2, 3, 4, 5, to the right 3. Equation, y equals mx plus b. Y equals negative 5 over 3, x plus 1. These that I have circled are weird ones. We're not going to worry about the slope and the y-intercept for this. We're going to say that on this one, the y value is always equal to negative 1. Doesn't matter how far left or right you go, the y value is always going to be negative 1. On this one, our y-intercept is negative 2. We need to find other perfect corner where it matches the grid with the perfect corner, so let's do these 2 points. Up 2, to the right 4. 2 over 4 simplifies to be 1/2. Y equals mx plus b. Y equals 1/2 x plus a negative 2. We need to fix those signs up. 1 over 2x minus 2. 2 more to go. Got a strange one here. This one is going to be x equals negative 3. The reason for that is because it does not matter where you go on that line, the x value is always going to be negative 3. Next, we have a place where it catches a corner there. It looks like it does right there, but let's look closer. It does not. To get the next perfect corner, we've got to come all the way down here. And so for that one, we'll pretend that our y-intercept is 2.3. And then the slope is going to be negative 1, 2, 3, 4, 5, 6, 7, 8. And across 3, 4, 5. Negative 8 over 5. Equation, y equals mx plus b. Y equals negative 8 over 5 x plus 2.3.